Unit 4, we're still in derivative world. Okay, I think we stay in derivative world through Unit 5, if I'm not mistaken. Today we start off with its interpretation of the derivative in context. So we kind of already talked putting derivatives into words or taking words and translating it to what it looks like as a derivative. Okay, so some information to read through here. So in our last 2 units, we've defined the derivative graphically, algebraically, and numerically as the slope of the tangent line and instantaneous rate of change at a point. In this lesson, we want to interpret the meaning of the derivative in a verbal manner, so as it relates to the context of real-world problems. A few names here. Newton. When Newton was developing his ideas of the infinitesimal calculus, can't say that, namely when given a fluent, or what we called function, to find its fluxion, what we call derivative, his thinking was concentrated on velocity. But today we know the derivative is important, reaches into so many other areas involving rate of change. So we've already talked about velocity. And if you recall, velocity is the derivative of position. Okay, velocity is that rate of change. So there was Newton, and then there was also Leibniz. And when we look at the Leibniz notation, he stated the variable y depended on x. And if y equals f of x, then the derivative could be expressed as dy over dx. Okay, so that's our Leibniz notation? I can never remember. Whereas Newton is more the y prime type of person. If we allow ourselves to think of d as representing a small difference in some process, we're reminded that the derivative is simply the limit of ratios in the familiar form. So dy over dx, think change in y over change in x, which is also the delta y over delta x, okay, or f prime of x. We've talked about d dx. That is the meaning the derivative with respect to x. When you're asked to take d dx in front of something, it's saying take the derivative with respect to x. And so what we generally do is we're taking the derivative of y, or the derivative of f of x, with respect to x. What else do we have? Leibniz notation, that dy dx, we've already talked. It's a little bit harder to write, but sometimes it tells us a little bit more. It's a little more cumbersome when you need to specify the exact x value where you need to evaluate the derivative. The benefit is you can read more about the rate because of the dy dx. So just remembering that f prime of 3, that's the derivative evaluated at 3. Dy dx, and then with the evaluation bar, evaluated at x equals 3, is the same thing. Okay, and you've seen both of these notations already, so that's not new. Okay, we're basically going to look and try and interpret some things back and forth, okay? So, example 1, the background. Sean is cleaning out his saltwater fish tank and needs to drain some of the water in order to adjust the saline levels. If the volume of the tank, V, is in gallons, is being drained over time, T, in minutes. What is a meaningful interpretation of the following statement as it relates to Sean's fish tank? And they say dV dt evaluated at t equals 3 equals negative 2.
Yes. 2 gallons.
Say it louder.
2 gallons drained at 3 minutes.
Almost. So you said there's 2 gallons drained at 3 minutes?
Yep.
Or is it every 3
How
minutes?
do I want to say? I'm trying to think if the every 3 minutes is... Because when I say that, generally when you look at this, it is... So the rate at 3, the rate is changing at 2. And so at 3 minutes, the tank is being drained at 2, what are we in? Gallons a minute. Okay? So I know it's a very slight difference, but there is that slight difference there. Now, we talked draining for 2 reasons, yes? because it mentioned drain, but then what's the negative mean? The negative means that we are, it's decreasing, right? T equals 3, so we know that's our time. dV dt tells us this is a change in volume over time. Okay? So, I say mine specifically says at 3 minutes, the fish tank is being drained at I actually use the word instantaneous rate of 2 gallons per minute. Because IROC, right? Instantaneous rate of change is your derivative. So. And there's going to be a little bit of, flexibility with what you write. So at 3 minutes, the fish tank is being drained. And I'm going to say at an instantaneous rate, but you could also just say rate and still be okay. Instantaneous rate of 2 gallons per minute. Okay. Wow. Okay. So I had something else written in mine I was looking to see, but I don't feel like it's necessary. I mean, I just pointed out that dV of dt evaluated at 3 would be the same as saying v prime of 3, right? V prime of 3 equals negative 2, and we already discussed the negative means it is draining, decreasing. So, okay. That's the type of stuff we're doing, going back and forth with today, one way or the other, being able to interpret and put all the details together. Sometimes easier said than done, sometimes perfectly easy. So, okay. Just like any other language course, we need to use proper names, spellings, grammar, conventions. There are many real-world functions that depend on variables other than x, y, or time. Learning to read and write the correct notation will help you succeed on free response prompts, okay? On the multiple choice, there's not a lot about labeling, okay? That's not usually an issue. It's a free response that they want you to put appropriate labels on, okay? And understand what all that means. Okay, so proper notation here. We're being asked to read the scenario and write the proper notation for the derivative. The Alberta tar sands are one of the biggest oil reserves in the world, yet extracting the fossil fuel costs more than the profits made. If the cost C in dollars to extract a barrel of oil is losing $3 on every barrel, write the derivative. Okay, so they gave us a couple of variables here, yes, or at least one. They told us that C is going to be cost, right? And that was specifically cost in dollars. What else did they talk about? I guess they didn't give us the other variable, did they?
They didn't.
No, but what are we talking about?
Barrels.
Barrels. Okay. Yeah. So I'm going to go with the obvious and use B for barrels. And with barrels, we're just talking, because it talks about the cost to extract a barrel of oil. So when we talk about barrels, we're just talking about the number of barrels. How many barrels are there? It's not like we don't talk about gallons of oil in the barrel or anything like that. We're just talking about a barrel of oil. Okay? Now, with that in mind, okay, the cost in dollars C to extract a barrel of oil is losing $3 in every barrel. If we talk, how do I want to do this? You know how you'll sometimes see something like y equals f of x? Okay. if I try and put that in terms of C and B, the cost is in terms of what? It's based on how many
Barrels.
barrels. So my C, whoops, gosh darn it, what did I do? My C is the idea of, I'm going to write it as F of B, because that's just kind of insinuating the idea that the cost is based on the number of barrels. Okay? You put so many barrels into your function, you're finding the cost. Now, if we're finding the derivative, ways to write the derivative here. And we're going to get to a specific here in a moment, but we could say y prime, right? More often, though, we would say, well, I guess I point at C and said y, didn't I? F of B, how do we write the derivative there?
F prime B.
So one option would be to say f prime of b. That's more of your Newton thinking. Okay. What about if we talk about Leibniz?
dy.
So instead of dy over dx,
DC over
db. That's my initials, db.
okay, so we're talking about the change in cost in relation to the change per barrel. Now, what is this? What is this equal to? What?
3.
-3 because we are
Losing
losing $3, right? And we're losing $3 what?
every barrel.
On every barrel. So if we put a label there, it's -3 cost per barrel, so
Dollars.
dollars per barrel. For some reason, I had to stop and ask myself if barrel had one L or two L's.
I put it with 2 L's, but it has one.
I almost put mine with two L's. And then I looked back and said, oh,
No.
The word barrel just.
I think I just don't usually write out the word barrel because it does not look right to me either. But That's
the
true.
only time I talk about barrels.
yeah, Cracker Barrel. Okay. Okay, so the piece I'm looking at here, guys, this right here, okay? We wrote a lot of information, but the derivative. The derivative is the -$3 per barrel expressed. DC over DB is what expresses the most information there. Okay? Try example B. The Deepwater Horizon oil spill is regarded as one of the largest environmental disasters in American history. The oil leak was discovered on April 22nd, 2010. BP originally estimated the flow rate was about 790 cubic meters per day at the end of the first week. Okay. Because that's the units.
That's American.
Everybody else uses meters.
Everybody else uses meters.
But actually, wait, this wasn't the one that was up in Canada, was it? Or was the Deepwater Horizon oil spill? I guess it says in American history, but there's a real big one up in Canada at one point. Doug's gonna look it up for us.
Okay.
He's in the process. I see him typing back there, and he's looking it up. So, sorry, history. There's a reason I'm a math teacher, not a history person. Okay.
I'm more of an anatomy person. I don't know what it is.
Thus, you want to go into nursing, right?
Exactly.
It was
Okay.
off the coast of the United States in the Gulf of Mexico.
Oh, I'm in the.
You're way up there.
I was thinking like Canada, like almost like Alaska area, but
Oh.
okay,
Well,
well,
for a while.
I'm wrong.
It's very tropical and I'm not.
Okay, I don't remember this one. I don't know. I'll blame it. I was pregnant with Natalie at the time. Very pregnant with Natalie at the time, so that's what I'll blame it on. Okay,
Natalie was born in 2010.
June 3rd.
She was born in 2009.
There was 09.
Yeah.
Well,
she's
but Natalie is
older.
very young.
Okay.
I mean, like Natalie, she will probably graduate and then turn 18 a few days later type person.
Oh.
Whereas,
Really young for her grade.
whereas Claire is on the
Claire's-
opposite end and will be
Literally
turning
first
18
day of
in the fall
September,
of, at the beginning of her
I'm
senior
just in the
year.
middle.
I'll be turning 19 in March.
Okay. We're unfocused. I'm unfocused. Okay, guys, so What variables do we need to talk about here?
Meters.
Okay.
Meters, cubic meters.
What is that cubic meters? It is the, what is it describing?
The,
The
The
range.
flow rate of the oil.
And what kind of unit is that?
Oh, it's meters cubed.
That's not what I'm asking. How do I get you there?
It's a cube.
What is meters cube a label for? Cubic meters are volume, yes. So when we're talking about this flow rate, the oil leak, we're talking about the change in volume. So I am going to use V for volume, and that volume is being measured in cubic meters, yes? Okay, volume is a very common derivative type thing. We also need to talk about, with so many cubic meters per day, yes. So we need to talk about, I'm going to use T for time. But what is our time measured in?
Days.
In this particular case, it is in days. It wouldn't have to be in days, but that's what this one's talking about, right? So when we think about our function here, like earlier it was C equals F of V. This one's going to be what?
V equals F of T.
Okay. This is volume measured in terms of time, right? So volume equals F of T. Okay, ways to write this.
dV over dt.
dV dt.
Evaluated at T equals 1.
Evaluated at T equals,
When do we want there?
no,
7.
7 because it's a week.
because our information that we're getting ready to write, the flow rate was about 790 cubic meters per day at the end of the first week, and we know a week is
5 days.
7 days. And our time, we listed it as time in days, yes? So dV dt, evaluate at T equals 7, is equal to
790 meters cubed day.
cubic meters per day. Okay. What's the other way to write this besides dV dt?
V prime.
Well,
Time of T.
we were using F though, right? It'd be F prime of, what number are we putting in here though? 7. So we could also say F prime of 7 is equal to 790 cubic meters per day. I'm trying to think, do I have anything else? Okay. Notation, right? This is all about understanding the notation, putting it into play. Okay, shall we talk about some gorillas?
Yes. Guerrilla warfare.
No. The population P of the endangered mountain gorilla has an ongoing study tracking the number of gorillas since 1992. The population increased by 114 gorillas during 2003 of this same study. Okay, they told us to use
Population P.
P for population.
I think we should use T for time in years.
Okay. Good variable for time is T, but this one is going to be, we're talking about years here, yes? So this time when we talk about time, this is going to be time in years. If we think about this as a function, the what? Yeah. It's a population based on time, right? Okay, so the function is based on time.
So that'd be dp over dt.
Okay. So we can talk about it as dp over dt.
Evaluate
Evaluate at
t equals 11.
t equals 11. Why 11? Because we're smart cookies that can do subtraction and say 2003 minus 1992
Didn't even attempt.
is 11. Okay, sorry. Minor details. Some of us can't subtract when put in the point of having to subtract. I forgot. Okay. And what's the other way to write this? We'll give what the answer is here in a moment, but this is f prime of 11. Yes. Okay, so you can write it. Those are equivalent things. What is this? Whichever way you write it, what is it going to be equal to? F prime of 11 is 114 gorillas per year. I need an abbreviation for gorillas. Like, that's a big word to write out there. Okay, you're seeing some of the equivalencies, right? It's all about notation, figuring this out. Okay, ready to try 3? Example 3. We're going to be given a situation here, and our job is going to be to explain what these pieces are, what they are in words. So, suppose a planet is discovered in 2024 and is named Newtonia. If the alien population, P of t, is recorded in millions of aliens, and t represents the number of years since the planet's discovery, explaining the meaning of each of the statements below. Okay, so let's see. Population, P of t, and notice it is recorded in millions of aliens. That's going to be useful information, right? So we have to take this all into account. T represents number of years since the planet's discovery. Okay. P prime of 3 equals 0.5.
It's 3 years after it was discovered, there were only 500,000.
Okay, say that end part again. I couldn't hear the end part, sorry.
So after 3 years of discovery, there was 500,000 aliens.
Yeah. Think. So you're doing more not the derivative of, you're just saying more P of 3 equals 5. 3 years after the fact, there are 500,000 aliens.
Increasing by 500,000 after.
You got to throw that increasing at a rate is the direction we need to go here. Okay, and that's the difference between P of 3 versus P prime of 3. Okay, so I have mine as in 3 years, or in t equals 3 years, and I even put 2027. You could say in 2027. That would be legitimate to say. Okay, the population on Newtonia will be increasing at the rate of 500,000 aliens per year, which is the 500,000 that Doug said, right? Could you also say 500,000? You could. 500,000, 500,000, those are equivalent values, aren't they? Okay. So NT equals 3 years, 2027. population on Newtonia. Could you just say the population?
Yeah.
You could. Will be. Why are we saying increasing?
Because it's positive.
Because it's positive. Silly question to ask, maybe, but it's positive. Will be increasing at the rate of, and I wrote mine as 500,000 aliens
A year per year.
per year. Because it's a rate, we need to talk about how often that rate is happening. Okay, there's some flexibility there. There's some ways you can go right, there's some ways you can go wrong. Okay?
Next one.
And with this one, P prime of 3, this could also be written as dP, the change in population, over the change in time, right? Evaluate at t equals 3 is equal to 0.5. So that's, not something they asked us to do, but that is your equivalent statement there. Okay? B.
After 5 years, there are 7.5 million.
Oh, you just switch it. Shoot, I was trying to figure out what you do with the -1.
I know.
Thanks.
So this is P
Inverse.
inverse, right? What does inverse do? Takes your input and your output and it switches them. Now, I'm going to write mine kind of different from Doug's in that, I technically don't see what's wrong with what Doug said because he gave the appropriate labels, right? Okay. I have it more just like I'm stating this first. So the 7.5 is my population, right? So the population will be 7.5 million. And the 5 is your time. So in 5 years, or 5 years after 2024, I guess.
I would put in 2029 population. So 5.
Right. And you can say that because mine says the population on Newtonia will be 7.5 million aliens 5 years after 2024 or in 2029. As long as you're not just saying, you want to be careful not to just say in 5 years. Because it's 5 years from when. Okay, that could be a sticking point. Okay. So. Population on Newtonia will be 7.5 million aliens. That's a lot of aliens. 5 years after 2024, or in other words, in 2029. Okay, so just realize this is going to be your population and this is going to be your time, right? Because they are switched. Okay, the fun one. The derivative of P inverse of 7.5 equals 0.75.
I would guess that it's probably
Well, we gotta start somewhere.
Is it
After-
just? Sorry.
at 5 years after discovery, the population is growing by 3/4 million aliens per year.
After 5 years.
You got some right pieces. I'm not sure where the 5 came into this problem because there's no 5 in this problem.
Well, we had the inverse of
But you're using the numbers in this problem.
Is it after like 3/4 of a year?
Well,
And the population will be growing at a rate of
Okay.
7.5 million?
so if we're starting with So, okay, so you guys are realizing, let me pick,
When the population is 7.5 million, it's growing by a rate of 3 million.
okay, so we do have that derivative to think about. So yeah, when the population is the 7.5, that's my input, right? So when the population is 7.5 million aliens, then you're talking about the 7,500s, right? Or 3/4. I think you guys said 3/4, didn't you? I mean, I have 3/4, okay. So now, how I have that written, though, is it takes 3/4 of a year for the population to increase by 1 million aliens. Now, that is in relation to, it's recorded millions of aliens, right? So a unit of 1. Now, I'm trying to think, what I'm trying to sort out is what's right and what's wrong. And that's hard to, I think there's a lot of variations on the right option is what it comes down to. Okay, so let me put mine up there, and then when the population is 7.5 million aliens, it takes 3/4 of a year for the population to increase $1 million. Bless you. Bless you? I lost track there. And I guess mine actually says to increase by 1 million aliens, but same meaning of what I had. And I hope you guys can read what I'm writing, because I feel like I'm writing really sloppy today. But I think it's readable. Okay. Are we getting the ideas here?
So, what they want us to put of a year, or can we put per night?
Oh, like instead of saying 3/4 of a year, could you put 9 months?
Yeah.
You could. That's an equivalent measurement.
Oh.
Just like over when we said 5 years after 2024, or we put 2029. It's the equivalent measurement. Okay? As long as you're giving equivalent measurements and they're labeled appropriately. Like you said 500,000 earlier, I said 500,000. Same thing. Okay? Okay. Continue on a little bit more. You're getting a flavor of what you're going to be doing in homework. It's just trying to put it all in words. So, okay. The next examples will show how clues from the units can help you recognize interpretations of the derivatives as they relate to real-world scenarios. So, suppose you launch a water balloon from a giant slingshot. Let S of t give the distance in feet that the water balloon traveled from its initial starting point as a function of time, t, in seconds. They want to know what ds dt at t equal 2, or s prime of 2, equaling 38 feet per second, what that all means then. And one thing I'll ask, what is s prime going to represent? Velocity, yes. Because we're starting with s of t, and s of t is your position function, right? So if f of t is position, then s prime of t is velocity. Okay. Okay, so what do we know? At what time are we talking?
Two
2.
Okay, 2 what?
seconds.
Seconds, right? So when t equals 2 seconds, what is this water balloon doing?
It looks like it's climbing 38 feet a second.
It's what?
It's possible.
Increasing.
It's positive, and what is it that's positive, though? It's the
Oh, it's
velocity?
Yeah.
Okay. So it's a positive velocity there. So when t equals 2 seconds, the balloon is, let's see, do I want to say traveling? Moving? Okay, because s prime of t, s prime is velocity. So that's talking about kind of like speed we're moving at. I can't use the word speed exactly for velocity, but it is moving at that velocity of 38 feet per second. Okay, so one thing to note here is connect. When they say position and you see derivative of position, you have to be able to connect that that is velocity. Okay, so put something down. When t equals 2 seconds, the balloon is moving at a, and I guess I'm just saying moving at velocity, not increasing at velocity, because velocity is a description of rate of change. Oh, actually mine says at an instantaneous velocity of 38 feet per second. Again, does the instantaneous have to be in there? No, it's just, you know, knowing that word is helpful. Well, instantaneous, right? Nope. Instant?
Earlier, I was like, I think she forgot an A in.
I did spell it earlier too, didn't I?
Yes.
Because earlier I
I was
remember
like
thinking,
staring at it, and I was like,
yeah. Earlier I remember thinking, did I spell that right? And then I never went back and checked it. Where was it? Oh, it was right there. Yep. Just go with it, okay? Instantaneous. I guess it's a hard word for me to spell, okay? That's the best I can do for you. Okay. 5. The total cost C in dollars of an airplane flight is a function of the number of passengers in, can be calculated by derivative airlines using the function C equals F of N. What does it mean to say F prime of 182 equals 58?
When there's 182 passengers, the cost is increasing at a rate of $58 per passenger.
Some variation of that, yes?
Yep.
There's lots of different ways you can rearrange that, right? But, yeah. Because I have the rate is changing $58 per passenger when there are 182 passengers. Rearranging, that's exactly what Doug said. Okay, so 182 is your input, so that is your passengers. 58 is the cost that is changing, and it is a rate. So I think I'm going to say when there are 182 passengers, the rate is changing $58 per passenger. Okay. Labels, throwing the word rate in there, those are going to be key pieces. Okay. Example 6. Last one, right? Non-potable water is being pumped into a processing center where the depth in feet of the water at time t in hours is given by y equals h of t. Interpret the following statements using proper units. H of 7 equals 5.
At 7 hours, the water is 5 feet.
Pretty much. No derivative here, right? Nothing fancy. Notice he threw in that the labels are feet and hours. You have to throw in those labels. But yeah, basically, at 7 hours, the non-potable water is 5 feet deep.
Why do you have to put it on the bottom?
I don't know.
If you just say water is
Don't worry. I seriously considered just leaving off the label non-potable and just saying water, but I'm trying to set a good example. Okay? I feel your pain. H prime of 7 equals 0.6.
I'm so confused. Why did I ever add any negatives in here? I should have added negatives.
Well, we can talk about it on this one, but H prime of 7 equals 6/10. What are your thoughts?
at 7 hours, the water is moving at a rate of 0.6 feet per hour.
And what part of the water is changing
You've got
the depth? Yes? Okay, so the depth of water is increasing at the rate of 6/10 feet per hour at t equals 7 hours. Again, I don't feel like, the depth of the water is increasing at a rate of 6/10, what was it? Feet per hour at t equals 7 hours. H inverse of 7 equals 9.
And then the
Supposed to be.
depth of the water is 7 feet. It has been 9 hours or something.
At 9 hours after. There's no derivative here.
Mhm.
So it's just at 9 hours or after 9 hours. Yeah.
Oh, I'm one ahead of you guys. Sorry.
That one is more stressful. I get it.
I was like, what are you guys doing?
I know. I'm like, why are you so stressed about this one? But okay.
Next one.
Okay. So what am I saying here? I lost it. The depth of the water is 7 feet after 9 hours. Okay. The derivative of H inverse at 7 equals 1.4.
when the water is 7 feet deep, it's getting deep at a rate of 1.4 feet per hour.
Say that again.
When the water is 7 feet deep, it is getting deep at a rate of 1.4 feet per hour.
Okay, so this is where I have to struggle with. Is that equivalent? I think. Is it? So, because it's the inverse, you know, earlier when we talked about that inverse, and also because it's a decimal, I'm trying to think. Well, I think it's more because it's a decimal, but or excuse me, because it's the inverse. So when the depth of the water is 7 feet, okay, what Doug said there, it takes 1.4 hours for the depth to increase 1 foot more, is what I'm looking at. And I think it's because we're doing the derivative of the inverse there that you're comparing it to what is the original unit. Okay? I know. This one is the hard one. It is. I'm not going to argue that one at all. So let me put it down and we can. The depth of the water is 7 feet. We know that's the depth because our input and output switch here, right? Then it takes 1.4, and that is hours, right? Yes. Hours for the depth to increase 1 foot more. It's because we're doing derivative of the inverse. That's the catch there. So derivative of the inverse because that derivative is rate of change. And so when we look at that rate of change, it's hard to do a rate of change with the 1.4 hours. And so it's the 1.4 hours related back to the original unit, increase 1 foot more. Earlier with the, was it the gorilla one? Is that what it was? No, Newtonian, it was aliens. Sorry, my apologies. It was that 3/4 of the year, and that is for the population to increase 1 million aliens because that was the rate. Okay. Okay, guys. Work through these.
Do we only have 2 units?
The answer key is available. With that in mind, really work to not look at the answer key until you try the problem. Okay, or try the section or whatever. This also does mean homework is due Monday. And I probably need to make sure I tell Kylie and Hannah that they really need to, over the weekend, try to get caught up on 4.1 or they're going to be really behind. Okay?